Since time immemorial, First Nations people have reverently and respectfully lived with the natural world. They have a deep connection to their land, water, and ecosystems that are central to their culture, spirituality, language, and livelihoods. Through this intergenerational experience and observation, Indigenous peoples were and are among the first to notice climate change, and they have critical knowledge for navigating and adapting to it. This ancient knowledge and intergenerational wisdom is flexible, fluid, and adaptive as it evolves through relationships with the land and other beings. This knowledge evolves from and is responsive to the natural world, which makes it ideal for developing and advancing meaningful climate solutions. In the following video, you will see how Black River First Nation in Manitoba, Canada, is addressing the issue of climate change within their community. There is plenty of evidence that Earth's climate has been much colder in the past, and there is evidence that it has been much hotter in the past. We currently live in an interglacial period. The last ice sheet vanished about 10,000 years ago. Black River is located on the shore of the remnants of glacial Lake Agassiz that was formed when the ice sheet melted. In our first image, we see evidence of climate change. These deep scratches in the rock, known as striations, were caused by a scouring effect from the weight of an ice sheet that was 1 kilometer thick. Other rocks embedded in the ice were under such pressure that they literally gouged into the hard, igneous rock. Variations in weather patterns over time created fluctuations in the level of Lake Winnipeg. This photo shows very low water levels that resulted from 2 back-to-back drought years in 2020 and 2021. A warming climate results in greater survival of invasive species. This cluster of adult zebra mussels stranded on a rock will likely not survive, but millions of other mussels will. This invasive aquatic plant, known as Eurasian milfoil, entered the Canadian waters via cargo ships. Warmer waters have created ideal conditions for it to reproduce. It can choke out competing vegetation and clog creeks and streams. The monarch butterfly is said to be a bellwether species, in that its population is highly dependent on climate conditions to make its 4,000-kilometer migration from central Mexico to southern Canada. More severe weather, such as windstorms, drought, late frosts, make it very vulnerable to changes in our climate. Windstorms over Lake Winnipeg have caused surges in water into Black River. These storm surges have created excessive shoreline erosion, causing trees to slump into the river and creating silt deposits, which harm fish spawning habitats. With help from the Jordan's Principal Program, students were able to get outside and do field research, such as taking water samples, measuring snow depth, and assessing ice thickness. And this all-terrain vehicle, equipped with a snowplow, made our monitoring trips much, much easier. In this image, we have students monitoring snow depth. These measurements are taken weekly and compared to baseline data. Greater fluctuations in precipitation are expected as our climate changes. Connected to this, these students are measuring the thickness of ice on Black River and the Ohanley River. A warming climate will create unsafe conditions for travelers on lake ice and river ice. Next up is routine water sampling. These students are analyzing water samples that are taken year-round to monitor such things as oxygen, saturation, and pH level. Warm water holds less oxygen and can lead to fish kills. This device will allow us to track water temperature under the ice all winter long. Water temperature monitors are placed under the ice, and they are well marked for safety purposes, since the river is the highway through the community for snowmobiles. These students are measuring the trees inside a research plot to track long-term changes in the health and productivity of the forest. The first step is to identify the species found in the research plot before they are tagged and assessed for age and diameter. This is a tag showing Black River Plot 2, tree number 1001 for research. Each tree in the research plot is equipped with a data tag. Measurements of its height, diameter, and general state of health are recorded. A long-term study will detect changes in forest ecology and will monitor the effects of windstorms, drought, flooding, and insect and disease infestations. Students will also examine the forest canopy for signs of fungal growth, disease, insects, and wind damage. Another important tool that we are using is our remote weather station, which is key to tracking weather data daily. Changes from baseline data will allow the community to detect changes from long-term average weather data. Students here learned about climate change and food security by spending the day with commercial fishermen on Lake Winnipeg. Invasive species, more summer storm surges, and a rise in invasive species all present challenges for fishers on Lake Winnipeg. Drones today serve a variety of functions, from capturing aerial photography to assisting in delivering food and packages. But one particular service may end up being their chief contribution, by acting as mitigating forces against the impacts of climate change. These little gadgets are now capable of everything from fighting dwindling bee populations to reducing carbon emissions to tracking changes in wildlife population and gathering water samples. Perhaps the most prominent way in which drones can help fight climate change is by assisting with data collection. Drones can travel to places where humans cannot easily go, thereby reducing research costs and increasing the accuracy of data collection. Any community can and should assess their vulnerability to climate change. It is their responsibility to mitigate the risks by taking a bird's-eye view and then looking for things that can help their community safely navigate any climate changes ahead. They should look for such things as where in the community is there too close of an interface between the forest and residential buildings? Can you create a buffer of 75 to 100 meters to allow for a fire guard break in the event of a wildfire? Which of the infrastructure in your community is most vulnerable to flooding? Roads, bridges, culverts? In the event of an emergency, where would escape routes be designed? Is there only one road in and out of your community? There must be a plan in place for evacuation if an event should occur. Does it make sense for your community to have muster points for people to gather in the event of severe weather? In other words, we cannot and must not stand around and hope for the best, but rather plan, prepare, and make a concerted effort to adapt to what is coming at us. We cannot air condition our way out of this problem. We need to be mindful of elders and young children who are especially vulnerable and plan to protect every member of our communities.